The new section is entitled, and should be entitled, to as Introduction to Parallel Lines. Oddly enough, we're not going to deal with parallel lines. Not at least initially. So we're just going to do a lot of definitions right now. If you have two lines, parallel or not, and you draw a line that crosses both of those lines, this is called a transversal line. A line that crosses two lines is called transversal. Let me write it down a little bit more clearly. Transversal. And that line, the transversal line, pretty much made up 8 angles. Angle 1, angle 2, and I'm not saying these angles are equal by any means. Angle 3 by putting the same number of slashes. Angle 4, angle 5, and 6, and 7, and 8. Okay. Now, I'm going to talk about regions. We're going to talk about regions. The regions are pretty simple. The region in here, it's in between the two lines. It's interior. This is the interior region. That is, angles 3, 4, 5, and 6 are interior angles. And angles 7 and 8 are exterior angles. Exterior regions, excuse me. And up here is also their exterior region. So angle 1 and 2 are exterior angles. Angles 3, 4, 5, and 6 are interior angles. And angles 7 and 8 are exterior angles. So if you are in between the two lines, these angles, those 4 angles, are interior angles. These angles outside are called exterior angles. So 1 and 2 are exterior, 3, 4, 5, and 6 are interior, and 7 and 8 are back to outside. So those are exterior angles. Okay. Now, we want to now talk about alternate interior angles. If you have two lines, again, not saying they are parallel, and you cut them by a transversal, anytime you can make a Z, and Z can be written that way, it can be written this way, it can be on the side, it can be, quote, backwards. Basically, you can rotate that Z any way, and that's what I call a Z. In fact, instead of going that way, it can even go like that. That's a Z. Okay? So here is a Z. And basically, these angles in that Z, these angles in the Z, and down here it becomes a bit more tricky, but those are the angles. Those are interior angles. So angle 1, 2, 3, 4, 5, alternate interior angles, 7 and 8. Here is my Z. It caught 3 and 6. 3 and 6 are alternate interior angles. Also, Here's another z. Here's another z. Look at that. We have yet another z. And that captures 4 and 5. 4 and 5 are alternate interior angles. Okay, anytime you get that z, you have alternate interior angles. Z can go very strange ways. That's also a z. That's also a z. These two angles are equal. That's a z. Sorry, they're not equal, the alternate interior. Those two angles are alternate interior. So that's how you find alternate interior angles. And given any two lines and a transversal, you have two pairs. Always two pairs. Okay, now we want to talk about alternate exterior angles. Now remember, angle 1 and 2 are exterior, and angle 7 and 8 are interior. Actually, why don't we first talk about corresponding angles? Okay. Let me draw this again without all the writing on it. Let's talk about corresponding angles. Here's one line. I'll draw the other line in a moment. There's a transversal. 1, 2, 3, and 4. I'm going to call 1 the top left angle. I'm going to call angle 2 the top right angle. Angle 3, the bottom left angle. And angle 4, the bottom right angle. And now we have 5, 6, 7, and 8. Okay, the top left angles are corresponding. 1 and 5. Top left are corresponding angles. The top right, 2 and 6. 2 and 6 are corresponding angles. Their bottom left angles, 3 and 7, are corresponding angles. Now, if the two lines, line 1 and line 2, were parallel, then 1 and 5 being corresponding would be equal. 2 and 6 angles 2 and 6. Angles 2 and 6 being corresponding angles would be equal. And let's finish up this list by saying the bottom rights are corresponding angles. Okay. Now, if you, okay. All right. Now we talked about alternate interior. Now let's talk about alternate exterior. So these are the corresponding angles. And we usually always number it the way I did. 1, 2, 3, 4, 5, 6, 7, 8. It doesn't go clockwise. It isn't 1, 2, 3, 4. No. Each row horizontally goes left to right. 1 and then 2, and start from the left again, 3 and 4. Same with the bottom. So now, what are the alternate exterior angles? Oh, let's leave that. The alternate exterior angles. Well, you have one. One's exterior, and the only exterior angles and the bottom are 7 and 8. It's the ones that don't correspond. Well, okay. They shouldn't lie on the same side of the transversal. 7 lies on the same side. That's why 1 and 7 are not alternate exterior. Okay, angle 2 is an exterior, and it's on, this side of the line. It's on that side of the line. I don't want to say right or left, because if the transversal is horizontal, well then which is right and left? Okay? These angles are on the same side. So it's not angle 2 and the exterior 8, but rather 2 and the other one. The two exterior angles that do not lie on the same side of the transversal are alternate exterior angles. Here is the transversal. Look at that exterior angle. Go to the other exterior angles and pick the one that doesn't lie on the same side. And that's angle 8. So 1 and 8 are alternate interior. These are alternate exterior angles. They are alternate 2 and 7 are alternate exterior angles. They don't lie on the same side of the transversal. Okay, and they're exterior. Angle 2 is certainly exterior. So we're 7 and 8. But to pick the pair that the other angle that goes with 2 to be exterior, we don't pick 8 because it's on the same side of the transversal. We pick the other one, which is 7. Okay. So we talked about alternate interior angles, corresponding angles, alternate exterior. Corresponding angles, two angles are corresponding if they're in the same type of location. You always pick one from here and one from there. They have to be in the same location. Top left, top right, bottom left, bottom right. Alternate exterior angles. Well, first you have to know what interior and exterior are. Remember that 1 and 2 and 7 and 8 are exterior. And everything inside, 3, 4, 5, and 6, are interior angles. The definitions are nice. If you're inside, you're interior. If you're outside, you're exterior. And to be alternate interior, exterior, you have to be outside, and there are 4 angles outside. And you need to pick one from the one line. Say you pick angle 1, and now you go to the other 4 angles from the other line, and you pick an exterior angle, 7 or 8, that is not on the same side of the line of the transversal as angle 1. Angle 1 is on this side of the line, of the transversal line. So we pick 8. 1 and 8 are alternate exterior. Now, for alternate interior, we can basically say the same game. Angle 3 is interior. It lies on this side of the line. So you can play the Z game, which personally I like, or you can play the other side of their line game, the transversal line. Angle 3 is interior, but we want alternate interior. Well, it's either 5 or 6. But to be alternate, whether you're interior or exterior, it can't lie on the same side of the transversal. That is why 3 and 6 are alternate interior angles. So you can play the same game with, you have to be on different sides of the line. If you are exterior and you lie on different sides of the line, you are alternate exterior. But I do want to say one thing. One, two, three, four. Oh, okay. These two are exterior angles, and they don't lie on the same side of their transversal. They are not alternate exterior angles. You have to pick one from here and one from here. One is exterior, so I look at the other exteriors, which is 7 and 8. One is on this side of the line, so I pick 8, which is on the other side of the transversal. 1 and 8 are alternate exterior. Don't say 1 and 2. Nor can you say, for example, 4 and 3 or 3 and 4 are alternate interior angles. Okay. The next and last thing we're going to talk about will be concerning these angles. If the two lines that are cut by the transversal are in fact parallel. You have line 1 and line 2, and you come to know, probably because it's given, that line 1 and line 2 are parallel, and it is cut by a transversal. What is true is alternate exterior angles are equal, and alternate interior angles are equal, and corresponding angles are equal. So alternate interior angles. Well, angle 3 these are angle 3 is interior, and angle 6 is interior, but on the other side of the line. So angle 3 equals angle 6. Alternate interior angles are equal if the lines are parallel. Also, 4 and 5 are interior, and they lie on both they lie on different sides of the transversal. So angle 4 is equal to angle 7. And that's true for alternate interior. Now, alternate exterior angles, they're equal. Angle 1 is exterior, and angle 8 is exterior. And they lie on different sides of that line. Oh, you mean they're equal? Again, the angles have to be parallel. Likewise, angle 2 and angle 7 are exterior angles, and they lie on opposite sides of the line. Oh, they're equal. Angle 2 is equal to angle 7. But you know, opposite angles are equal. Angle 1 and angle 4 are equal. Angle 2 and 3 are equal. Angle 5 and 8, 7 and 6. But let's call it corresponding angles. Well, the top left angle, 1, is equal to the top left angle, 5. Angle 2, the top right angle, is equal to angle 6. All right? Angle 3, the bottom left, is equal to angle 7. In the same location, the bottom left. And the bottom right, angle 4, is equal to angle 8, the bottom left. Corresponding angles, there are 4 of them. For alternate interior and alternate exterior, there's only 2 for each of them. Okay. Now, let us put this together for a moment. I'm looking at alternate interior angles, and I'm looking at the fact (3 and 6). Does angles 3 real? So, do I have a silly mistake? 3 and 6 are equal. Oops. 4 is interior, and 5 is interior, but the opposites. This should have been a 5, sorry. Okay, so 3 and 7 are equal. So 3 and 7 are equal. But 3 happens also to be 6, and 7 also happens to be 2. That is, angle 3 is equal to angle 6, which is equal, not equal, but equals angle 7, which equals angle 2. These 4 angles are equal to one another, because I know that 3 and 7 are equal. So let's write it so you can see this. So angle 3 is equal to angle 6, but angle 3 also equals angle 7, and 7 equals 2. Okay, those 4 angles are equal. But you know what? Angle 4 is the same as 8. Okay? Keep in mind 4 and 8 are the same. But we know that angle 4 also equals angle 5. But angle 4 also equals angle 8. Oh, look at that. Angle 8 equals 1. You only have 2 angles going on. You only have 2 different angles going on. Okay, you only have 2 different angles. You have 4 of one type and 4 of another type. And there's even a connection between the types. You have just 2 different angles. 4 of the angles can be 50 degrees, and for right now, the other 4 can be 70 degrees. Angle 1, angle 3, angle 4, and angle 8, they're equal. Oh, line 1 and line 2 are parallel. Angle 1 and angle 4 are in the same location, they're equal. But opposite angles are equal. 1 and 3 are equal, and 4 and 8 are equal. That's one pair. Those are 4 angles that are equal. And then angle 2, just a little typo, just in a number. This should be angle 5. Angle 2 and angle 4, they're equal. They're opposite angles. Even if the lines are in parallel, opposite angles are equal. But since they're parallel, for example, angle 7 is in the same exact location as angle 4. So angle 4 and 7 are the same. But 7 is opposite to 6. Those are the same. Okay, now, one last comment. That angle is 180 degrees. That is, angle 1 plus angle 2 add up to 180. That is, they are supplement. They add up to 180. So not only are these 4 angles equal, and not only are these 4 angles equal, but if you take one from the top and one from the bottom, they'll add up to 180. Angle 7 and angle 4, they add up to 180. The reason is okay, so what went wrong here? Angles 3, Oh, I numbered them wrong. From left to right, they go. This is 3 and then 4. Okay, so angle 7 and angle 4. Okay, angle 7 corresponds to angle 3. Angle 7 corresponds to angle 3. Since the lines are parallel, that means they're equal. Well, 3 plus 4, angle 3 plus angle 4 is 180 degrees. But angle 3 is the same as angle 7. That is, angle 7 plus angle 4 is 180. There are just two different angles. If you come to know that angle 7 is 110 degrees, then all four of these angles are 110. And you know what? The others are all 70. There's only two different angles going on if the lines are parallel. If they're not parallel, you will have if they're not parallel, you will have four different angles. Okay, let me just show you that, and that will finish this. No matter what, angle 1, well, let me label them so I don't make any mistakes. 3, 4, 5, 6, 7, 8. Angle 1 and angle 4, there's no way out of it. Those are equal. Angle 2 and angle 3, they're equal. Okay, there's no way out of it. Angle 5 and 8 are equal, and 6 and 7 are equal. But you know what? 5 doesn't have to equal one of the angles up there. That is, angle 1 can be 110 degrees. That would mean angle 2 is 70. So then this is 110, and this is 70. But angle 5 can be 120 degrees. That means angle 6 is 60. And 5 and 8 are opposite. 8 is 120. 6 and 7 are opposite. We have four different angles. 110, 70s, 120s, and 60s. Now that's how you can tell that these angles, that line 1 and line 2 are not parallel. Corresponding angles are not equal. Alternate interior angles are not equal. They're supposed to be equal. If the lines are parallel, alternate interior angles are equal, and alternate exterior angles are equal. Corresponding angles are equal. Once you get one of those, just like when I say one, I don't even mean both alternate interiors. Once you get this, or that, or that, or that, you have parallel lines. Okay, that finishes up this section on Introduction to Parallel Lines.